Hey everybody, the purpose of this video is to get you some solutions to this dropping rocks off of a cliff quiz in Math 105. You got some point value things to talk about here. 2 points for starters. Google, why is there gravity? This is always a good thing. Why is there gravity? All right, let's see what we come up with. Why is there gravity? Department of Physics, Illinois, University of Illinois. Yes. Good question. I wish I knew, but that's the way it is. Scientists can explain lots of facts and effects of gravity and know why the Earth attracts an apple and why and how it falls. But do not know why gravity exists. Yeah, I remember reading or hearing years and years and years ago that there is a law of universal gravitation. Let me Google that for you real quick. Law of universal gravitation. I spelled that almost correctly. And we'll go with Wikipedia's here. This is fine. It's kind of a fun little equation. Here it is. F equals G times M1, M2 over R2. R squared, excuse me. The M1 and the M2 are the masses of the two objects that are being attracted. And the R is the distance between them. G is a gravitational constant, and F is the force between. And this is interesting because we understand the relationship between the gravitational pull and the masses of the objects, but we just don't know why the gravity exists. Kind of rad, actually. Anyway, that was the point. The point was that nobody seems to know why there is gravity, but we do know how it works. So anyway, here's a very generalized equation for position on Earth after you've been falling for t seconds. Oops, sorry about that. After we've been falling for t seconds with an initial velocity of v sub 0 and an initial height of h sub 0. So down here, I ask you to explain why, if we simply drop an object at a height of h sub 0, why the equation right here reduces to this if we're interested in how long it will take for it to hit the ground. Well, h will be how far it has fallen, and we want it to go all the way to the ground, which will be at 0. So we'll fall from some initial height h naught, which is some distance above Earth, above the surface of the Earth, and we want it to fall until it's fallen all the way to 0, which means it has fallen the entire distance. V0 would be 0. The number itself would be equal to 0 because if we're not throwing it down, we're simply dropping it downward, it has 0 initial velocity, which means this whole term will vanish. So you're left with 0 equals negative 16t squared plus h naught. Beautiful. And the last, that was the explanation here. And the last was just use the equation to figure out if the rock falls for 2, 3, or 4 seconds. So it's just a matter really of sticking in t equals 2, 3, and 4 into this little equation here and seeing what comes out as a result. And you can see that 2 is going to, let's just do 16 times 2 squared. That's going to give us a 64-foot cliff. Yep. So that's a 64-foot cliff if it falls for 2 seconds. If it falls for 3 seconds, let's see, it's 9 times 16, something that ends in a 4, 144 feet. And finally, 16 times 16, 256 feet. So you got a 64-foot cliff, you've got a 144-foot cliff, and a 256-foot cliff. This is when I start getting worried about my my rappel rope. If it falls for 4 seconds before I hear it, that means my rope's going to be too short. The reason I bring this up is because I heard Bear Grylls on Man vs. Wild or Running Wild with Bear Grylls, one of those TV shows, state that a rock falls about 25 feet a second. And that's wrong. It doesn't fall 25 feet a second. It falls faster the longer it falls. To a point. There is something called terminal velocity, but it's not going to hit terminal velocity unless you're dropping it off the top of El Capitan. So to think that it falls the same amount every second is kind of silly because it doesn't. It accelerates under the force of gravity. Anyway, I hope that helps, and we'll catch you in class. Hey everybody, the purpose of this video is to get you guys some solutions to this relative position quiz involving 2 box plots. We got some pharmacists and some non-pharmacists, and we are looking at adverse drug event rate detected. So it's a number of these things detected per admission. So we're looking for whether there's a difference, I mean, this is a 244 idea, but whether there's a difference, a measurable difference in the number of these adverse drug events noted by pharmacists versus non-pharmacists. So let's see what we got here. You don't actually have to understand anything about pharmacy at all to answer these questions. Which group had the higher median number of ADEs detected per admission? Choose one. Well, the median in your box plot is going to be the middle line in the box. So definitely the pharmacists. They worked up at about 0.3 per admission, and the median for the non-pharmacists was down around 0.1. So definitely the pharmacists. And what was their median? We just said about 0.3. Which group had the highest number of ADEs detected per admission? Choose one. Well, the highest number is going to be the furthest up the vertical scale here, and that's this guy right here, right up at about 0.6. So definitely the non-pharmacists. Don't confuse highest number of ADTs detected with highest median or highest usual number. Just the highest. Which group had the highest? The non-pharmacists had the highest. Whatever this number means, 0.6 is higher than 0.5. Which statistic is closest in value between the two groups? Choose one. Well, let's see. The mins are off by about 0.2. So is Q1. The medians are off by 0.2. Q3 looks pretty close. And the max. Yeah, of the three I listed, Q3 is definitely the closest. Which group shows more variability in their data? Pharmacists or non-pharmacists? I'm going to go with pharmacists. And the explanation is part 6. Look at the box plot. And look at this box plot. The box plot of the pharmacists is tighter. It only stretches from about 0.15 up to a 0.55, which means it's got a spread of 0.4. This one almost runs the gamut from 0 to 0.6. So less variability means less spread in the data as portrayed in the box plot. Okay, I hope that helped, and we'll catch you in class.